Hello, guys. Welcome to Ramta Solutions. Welcome to your grade 10 mathematics. Today, in our topic functions, we are looking at quadratic functions. These are also called these are also called parabolic functions. Okay, these are also called parabolic functions. Okay, they are also called parabolic functions, and they have the form y. Let me begin it as f of x equals y, which is they have the form ax squared plus q. Okay, they have the form ax squared plus q. So remember, I'm using y to say instead of f of x, you can say y. Okay, so what do all this mean? So this f of x or y is the output, okay, is the output, okay, which is the function. It is the output which is governed by this equation. And what is this a? So this a here has so many purposes. One of them is concavity. One of them is concavity. Okay, one of them is concavity, and another one of them is the wideness of the curve. Okay, wideness of the curve. Okay, and what is this f? It is the input. Okay, it is the input. So this therefore says to you, when we draw the the graphs representing this function, we are going to relate f to x. So this is y versus x that we are drawing. Then this q, this represents what we call the y-intercept. Okay, represents the y-intercept, and not only the y-intercept, it also represents the y value of the turning point. Okay, it is y value of the turning point. Okay, it is y value of the turning point. Okay, it is y value of the turning point. In addition to that, it also tells you whether it is, rather, you can call it a maximum or minimum point of a curve. Okay, all right. Now, let's look at concavity. So we're going to look at the value of a. So the value of a, let me just say this, the value of a, I'm going to give you a brief for the value of a. So this value of a, which is the coefficient, maybe let me say the value of coefficient of x squared. Let me put it like that. The value of coefficient of x squared. In our case, we used a, will be 1 with regard to concavity. All right, with regard to concavity, we say when a is positive, you have a smiling curve. All right, and then when a is negative, you have a frowning curve. This curve is concave up. All right, one that is smiling is concave up, and the one that is frowning is concave down. All right, is concave down. Okay, so as you can see, one that is concave up, the lowest value here is the y value of the turning point, but we are going to look at this later. Okay, so then what are we looking at? Then I said, remember that it represents concavity. All right, it also represents wideness of the curve. All right, it also represents wideness of the curve. All right, so wideness of the curve. All right, it also represents wideness of the curve. So with the wideness of the curve, I will take an absolute value, okay, I will take an absolute value. For when you have an absolute value of a being greater than 0 but less than 1, your curve will be wider. Okay, your curve will be wider. And when this a, its absolute value, when I say absolute value, I say whether a is positive or negative, it doesn't matter. Okay, so when this a is greater than 1, so now in this case, guys, with an absolute value, an absolute negative 2 is a positive 2. An absolute positive 2 is also positive 2. So an absolute value returns numbers in their positive sense. Okay, so if a is greater than 1, your function will be narrow. Okay, your function will be narrow. So for example, these ones here, they will be moving away from the y-axis, whereas these ones, they are moving closer to the x-axis. So let me show you, just to change the colors, let me show you. So let's say we have one. I'm going to draw it, this one here. Yeah, it's fine if I draw a if I draw in a white color. Okay, and then I'm gonna use a different color. Okay, I'm gonna use a different color. So this one here, this one here, this one here, its a absolute value of it is greater or equal to, is greater than 0 but less than 1. But this one here, its a, its absolute value is greater than 1. Okay, it's greater than 1. Remember, guys, I said even if it's -2 or -3, +2, what remains is that the absolute value will return the positive of it. Okay, so this is what we mean. Do you see now that now with this one here, when a absolute value of a, when it's greater than 1, it is narrow, meaning the curve approaches the y-axis. Now, when absolute value of a is greater than 0 but less than 1, it is stretched out from the y-axis. Okay, it is stretched out from the y-axis. Okay, so this is what we are looking at. Now, let's then look at, we're going to look at the value of q. So we're going to look at the value of q, right? The value of q, 1, it represents y-intercept. Okay, y-intercept of, it represents y-intercept of the function or graph. Okay, y-intercept of the function. This is to say where the function is cutting the y-axis. Okay, all right. And I mentioned two things. It is also the y value of the turning point. All right. 2, it is y value of the turning point. Okay, it is y value of the turning point. Further, if your a is positive, your function, remember, looks like this. So it is this point here, right? So this, we call it a minimum. Okay, it is a minimum. So when a is positive, q is a minimum. Okay, now if a is negative, your function looks like this. So q is a maximum. Okay, q is a maximum. Okay, and this is what is the meaning of all this. And I should also add, before I proceed, there's more. It also represents vertical shift. It also represents vertical shift. Okay, it also represents a vertical shift. Okay, now let's go. So the third point under Q is that it represents a vertical shift. So let's go. It represents a vertical shift. It it represents vertical shift. Okay, so what do we mean by saying it represents vertical shift? This means for the function to move up or down. So if q is positive, your function is moving up, and then if q is negative, your function is moving down. In other words, it is translated upwards when q is positive and translated downwards when q is negative. Okay, all right. So these are all we need to know about these parameters here. Okay, then let's look at the characteristics. So we are going to look at domain. In fact, let's begin with axis of symmetry. Okay, let's begin with axis of symmetry. Okay, let's begin with axis of symmetry. Okay, so with the axis of symmetry, for grade 10, it is x equals 0. Okay, for grade 10, it is x equals 0. But what is this axis of symmetry? This axis of symmetry is, so this axis of symmetry, what is it? It is a line, the line that divides the graph into two equal halves. Okay, it is the line that divides the graph into two equal halves. The graph or function, the graph into two equal halves. Okay, so if you look at it here, if this is your axis of symmetry is 0, and this point here is minus 2, this point here must be positive 2. If this point is minus 8, remember from the x-axis, okay? If it's negative 8, this one here must be positive 8 for as long as they are on the same horizontal line. Okay, if they are on the same horizontal line, it will be the same distance. From x equals 0 to the right, it's 8 units. Then from x equals 0, to the left, it's 8 units. Then from x equals 0 to the right, it must also be 8 units. In the same way as we can say from x equals 0 to the left here, it's 2 units. It must also be 2 units to the right. So this is axis of symmetry, right? So if you were to draw this in a piece of paper and you fold them on along this line will be embedded onto this one. Okay, this is what we mean by axis of symmetry. Remember, for grade 10, your axis of symmetry, x is equal to 0. That's your axis of symmetry. All right, great. Now, we then look at the turning point. Okay, we then look at the turning point. Now, let's look at the turning point. What is this? This is where the graph changes concavity. Should we say where it changes concavity? So this is the lowest. It doesn't change concavity. This is the lowest or highest point of the curve. Lowest or highest point of the curve. I want to say graph, but it's okay to say curve as well. Okay? It is the lowest or highest point of the curve. So, for grade 10, turning point will be the coordinates of the turning point. So the coordinates of the turning point will be 0 and the value of q. Okay? For grade 10 only. Okay? For grade 10 only, it is 0 and q. Whatever value of q, when you then say it's 0 and whatever value of q, that's your turning point. So remember, when a is positive, When A is positive, you say you have a minimum. That's your the lowest value. When A is negative, you have a maximum. That's your highest value. Okay? Great. Now, we are then going to look at, let's see, domain and range. We are going to look at domain and range. Okay. So for the domain, your hyperbola, oh, sorry, we're looking at the parabola. Your parabola quadratic function, any x value you can think of will always return a certain y value. So meaning all x values are allowed. Therefore, your domain is x is an element of real numbers. This goes for the rest of your life when you talk about quadratic functions. Okay, when you talk about quadratic functions. Now, with the range, and by the way, you remember in the previous video, we explained what a domain is, set of input values, and the range is set of output values. Domain, movement from the left to the right, range, movement from the bottom to the top, right? Good. Now with the range, we are saying, where is this function valid? So this function is valid in all y values, but not just all. There is a limit. Okay, there is a limit, so we need to be careful. So I should be careful. It depends on the curve that you have, its concavity. So if you have one that is concave up, if A is positive, remember your curve looks like this. And if A is negative, your curve is frowning. This point here, just to remind you, this point here, okay, this point here, just to remind you, it is 0 and Q. And this one here, again, it is 0 and Q. Okay, so what is the range? It will allow its y values, as you can see. So where do they start? From the bottom, you can say allows y is an element of real numbers, but it doesn't really take all y values. It takes y values where x is equal to this value here and above it. So where y, not x, sorry, where y is equal to this y value here and above. Right? Good. Now with this one here, we say it can take all y values, but there's a restriction. It takes which ones? When y is equal to q and below. So y is less or equal to q. Keep this in mind. This is your domain and range. Remember, it depends on your concavity, the concavity of your curve. All right. If it's concave up, it is like this. Y is greater or equal to q. If it's concave down, meaning y is a minimum, it's y is greater or equal to q. And concave down, y is a maximum. It is y is less or equal to q. Okay. This is your domain, or these are your domain and ranges. Okay. Great. Okay. Moving on. And by the way, there is an alternative. Another way could be other people prefer showing it like this. Y is an element of, where does it come from? From Q. Does it exist at Q? Yes, it does touch point Q. So it'll be Q included. Where does it end? Positive infinity. So then they write this. Right? So this is to say included. This is to say excluded because it's unknown. So we write this. Or alternatively, with this one, we can say it is y is an element of, where does it come from? It comes from negative infinity. Where does it end? It ends at q. Does it exist at q? Yes, it exists. So we will use a square bracket. You can use this one as well. Okay, cool. Remember, we are just using parameters. We haven't yet given them values, right? but you will see in the examples that we're going to use. Okay, great. So then we say, you know that when you sketch, you can use your table. So let's now say sketching them. So sketching parabolic or quadratic functions, which are parabolas, quadratic functions, sketching quadratic functions. So I will say sketch, this is an example, sketch f of x equals x squared. What do you need to do? I'm going to say, look for a table. Let's say x is minus 3, minus 2, minus 1, 0, 1, 2. And then what is f of x? Okay, what is f of x? It will be, let's see, minus 3. So where there's x, you put minus 3. Minus 3 square will be 9. Minus 2 square will be 4, 1, 0, 1, 2. Let me also put a 3 here. And then 9. All right. Now, you then sketch this. When we sketch this, what do we get? Let's begin. So drawing this, you will be given a graph paper. Okay. You will be given a graph paper. So let me see. I'll just say, let me just say this is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1. And then this is 1, 2, 3, minus, minus, minus. And this is 1, 2, 3. So this is y, this is x. Let me say minus 4 as well. Minus 4. Right? Okay. So we're saying where x is negative 3, y value is 9. But we have it there. Maybe let me change. Okay, it's fine. Where x is negative 2, y is 4. Where x is negative 1, y is 1. Where x is 0, y is 0. 1, 4, 9. And then we join it. Right? We join them. We join them. We join them. Right? So this is your f of x. Now, do you see? This is your, what is this? It is your quadratic functions. As you can see, a is positive. You can see the value of a is 1. All right? You can see here, the value of a is 1. What is the value of q? It's 0. As you can see, when q is 0, it means the turning point. Now, check this out. The turning point, where is it? It is 0. And you remember it was 0 and q, right? It was 0 and q. This is what you remember. What is it now? It is 0 and 0. Here is it, isn't it? Perfect. Now, what is the range? What is the range? The range, y is an element of real numbers, but where does it start? It starts at q, y equals 0. So we then say y is greater or equal to 0, as you can see. And this is what we said previously. Do you guys see that? And this is how you sketch quadratic functions. Okay? This is how you sketch quadratic functions. Okay? This is how you sketch quadratic functions. Okay? Perfect. Now, let's find equations of the parabola. Let's find equations of the parabola. So determining the equation of the quadratic function. Determining the equation of the quadratic function. Let's see. Okay. All right. So, which one should we think of? Okay, let's imagine now we have this one here. Let's imagine we have this one here, and then we have this point here. Let's say it's point A. It has coordinates 0 and +4. And then we have point B here. It's given to us as point B here is given to us as 2 and 8/3. All right. Now, the question says determine the equation of f. Oops. Determine the equation of f in the form y equals ax squared plus q. And then I'm going to say the x-intercept, and 3, the range. And 3, the range. All right. So let's look at it. So in our solution, let's see now. So solutions, let's see. So we have 1. We know this is y equals ax squared plus q. Oh, we have a y-intercept here. All right. We have a y-intercept here. Now, since we have a y-intercept here, we know that it is the value of q. All right. So we know it is the value of q, isn't it? It is the value of q. Okay, let me just write it step by step. It is the value of q, which is 4. All right. So a comment y-intercept. All right. Comment this is y-intercept. Okay. Now we have a point B, another point B with coordinates 2 and 8/3. 2 and 8/3. Correct? Whether it's x, you put 2. Whether it's y, you put 8/3. So this is 8/3 equals a, open bracket, 2, close, square, plus 4. This is 8/3 equals 4a plus 4. Then you have 8/3 minus 4 equals 4a, isn't it? Going to the next page, 8/3 minus 4 is the same as 4/3, isn't it? But minus 4/3. All right, so minus 4/3 equals positive 4a. Therefore, a equals minus 1/3. All right, so we can say f of x is minus 1/3 x squared plus 4, isn't it? Now, let's check. This value of a is negative, meaning we expect the graph to be frowning. Was the graph frowning? Yes, the graph was frowning. So since the graph was frowning, it's therefore expected that our value should be negative. So we are on point. All right? We are on point. Okay. Perfect. So the second question says the x-intercept. So we are looking for x-intercept. So with x-intercept, we must say y is equal to 0. Remember, f of x is the same as saying y. So f of x is equal to 0, isn't it? So what is this? Minus 1/3 x squared plus 4 is equal to 0, isn't it? Perfect. Now, multiplying throughout by negative 3, what do we get? we will get x squared minus 12 equals 0, isn't it? X squared minus 12 equals 0. Perhaps we can say x squared equals positive 12. Then we know x equals plus minus square root of 12. Therefore, x equals positive 12 or x equals negative square root of 12. Now your x-intercepts are square root of 12 and 0 and negative square root of 12 and 0. Okay, great. So for this one, if you're given such a question, you will need to factorize. If you cannot factorize, you can do what I just did here. Okay, perfect. Now, what do we have? Now, what we have is the next one. What is the range? Our range, easy peasy, it is frowning. So our range number 3, our range is y is an element of real numbers. Because it is frowning, y is less or equal to the value of q, which is 4. And then we are done. So this is how you look at your quadratic functions. This is all you need to know about quadratic functions. Okay, guys? So with that being said, ours ends here, and see you next time. Remember to keep in touch with us. You can follow us on social media. The links to different social media sites are given in the description of this video. And if you possibly watching on YouTube, you can like, subscribe, and share with your friends. So, bye bye.